from cotangent x. What is 1 over sine? Very good. Dx. So now, which function prime is cosecant cotangent or close? Negative cosecant x plus a constant c. Because cosecant prime is cosecant cotangent, but minus cosecant cotangent. That's why we needed the minus here. Questions on this? Questions? Okay. The last one here on this page is sine 2x, the integral from sine 2x over sine x dx. I will have difficulties if I don't remember what sine 2x equals to. Anyone remembers what sine 2x equals to? Should be in the front cover of your book. Double angled. Sine twice x is 2 sine x cosine x. Yes, I will simplify. What will I simplify? Very good. I will take the 2 outside. So this is the integral from cosine x dx. Which function prime is cosine? Just sine. So 2 sine x plus a constant c. Any questions? Now, all this, the next page, takes us back to evaluating other definite integrals. And we'll do as many as you want from here. But I would like to talk about the very last section because it's a very important section. It deals with a substitution rule. Okay? And I'll come back to that. That's the last part that we have to look at. So I'd like to move on to 5.5, last section, and then come back to the last problems from the previous section. And this is the last one. No more new material after this. So the integration by substitution. Okay. When do we substitute or use a substitution? Is when we want to make things easier. I don't need to use a substitution if it's a simple situation. But if it's a complicated situation, I would like to use another function that makes the integral easier to work with. So substitutions are not required, but they are a tool that simplify the integral for us. So for example, let's start with the first one here. I have the integral from 3x squared minus 6 to the third power dx. It will take me a long time to raise this to the third power. Not impossible. It's not power 15. It's power 3. So I could do that, right? Oh, I didn't copy the whole thing. I'm sorry. 6x dx. So it's 3x squared minus 6 everything cubed times 6x dx. So I could raise this to the third power. I could distribute 6x, and then I could find the integral. It's not such a big deal, but it will take me long. But if I use the substitution, let's say u equals 3x squared minus 6, it is very possible that this integral will become much easier to work with. Will the substitution, will that always be given to us? No. We may have to come up with a substitution on our own. Number 2, will only one particular substitution work? Not necessarily. I may find a substitution that works. You may find another one. another function that you will substitute for, and that will work as well. Okay? So keeping that in mind, when I change the variable or I use the substitution, and obviously when I look at this function, this is the function, right? This is the f of x and this is dx. This is what I would really want to get rid of. If I could get rid of this somehow that really bothers me by changing it to something else, like changing it to u or y or z, whatever variable you want, then I know for sure that the integral will become easier to work with. So for now I know that this will be replaced by u to the third. If I use this substitution, this piece will become u to the third. Do we agree? I cannot have in an integral, in a single integral, I cannot have more than one variable. So of course these have to go away somehow. I cannot have x and I cannot have dx. So of course every integral has to have d blah. If the function is in x, I have dx. If the function is in u, I will have du. Okay, so then I know how to find du for a function. A long time ago we talked about the differential of a function, which is normally y, right? dy equals f prime of x times what is dy equal to? What is the differential of y equal to? So if I'm given a function and I'm asked to find dy, what does it equal to? When we use the approximations, what did we replace dy by? Go back to your notes. Let's find dy. I need it now because without dy I can proceed. The differential of y, what does it equal to? I know you have it and I know you know it. It's under differentials and linear approximations. Very important piece of the puzzle. I'm given a f of x and I'm asked to find dy. Yes, what does it equal to? Excellent. Without this, I can't continue. Okay, so therefore, excellent, thank you. So du, what does it equal to then? This is my function. Now, and this is denoted by u. So I want, instead of dy, because it's denoted by u, I want du to be what? Excellent. So then now I know what this piece is all about. What is it? What do I replace this piece by? Exactly. And look at our new integral. Don't you love it? Just like that. Look how ugly it was initially, and look at what we accomplished now. So then, what function prime is u cubed? U to the fourth over 4 plus a constant c. The only thing is, I have to go back to the substitution though. Because of the initial integral was given in x. So what will you tell me to write?
3x squared minus 6 to the fourth.
Excellent. That's it. Did the substitution help? Tremendously. Otherwise, I would have had to raise blah, blah, blah to the third power, distribute 6x, and have 4 terms to deal with instead of just 1. Okay. Here's the next one in which the substitution is given to us. Although I think we got the picture. The integral from the square root of 2x plus 3 dx. We are told use u equals 2x plus 3. Of course, because I can simplify the square of a sum. This is what bothers me. That bothers me. This is not a scientific way of deciding upon the substitution. But I want us to build confidence on this and understanding. Okay, but I cannot have the square root of u and dx. That's not allowed. So obviously, if I transform the integral from an integral in x, and I transform it in u, I have to have the integral of something with u, and then what else attached to it? Exactly. So please tell me how much is du. That's the differential of u. Look carefully. You're on the right track, but I need one more thing. Yes, 2 dx. Awesome. So I don't have twice dx. Here's what I'm going to do. I multiply and divide by 2. Nothing happened. Multiplying by 2 and dividing by 2 doesn't mean anything. 1/2 in front. What do I replace this by? Awesome. What do I replace this by? That's it. So this is the integral of the square root of u du, which is much easier to handle. It's u to 1/2 plus 1. So 1/2 u to 1/2 plus 1 over 1/2 plus 1 plus a constant c. Yes, it needs cleaned up. And it also needs what else? After I'm done cleaning it up, substitute it back because it's the indefinite integral and I have to have it in x. So this is 1/2 in front. This is 3/2, so 2 over 3. U to 3/2 plus a constant c. And yes, I simplify, and I have 1/3. And u to 3/2, but u is 2x plus 3 raised to 3/2 plus a constant c. Any questions? Yes. Go ahead.
How do you inherently know you can just multiply by 1/2?
I didn't. I multiplied by 2 and divided by 2. But I put the 2 where I needed it, and I put the 1/2 where I didn't need it.
Why didn't you do 3?
I could, but what's the use of 3 when I needed it 2?
Oh,
Exactly.
alright, that's
Without the 2, I could have not replaced that. You can say, okay, I'm going to solve for dx. You can solve for dx and you still get the same thing.
But if you was 3x plus 3,
I would have multiplied by 1/3 and yes, yes. I would have had 3 at the top and 3 at the bottom, which is nothing. It's 1, but I needed the 3. I had to use the 3. Otherwise, I can create the du. Very good question. Good. Let's look at the next. Any questions? Okay, the next one is the integral from x squared over the cube root of x cubed minus 1 dx, and they are suggesting x cubed minus 1. Okay, fine. So if that's suggested, what will this equal to, the bottom? Right. or u to 1/3. Excellent. But I'm missing a piece of the puzzle, which is awesome. Awesome. Good. Yes?
dx.
3 x squared dx. Right? X cubed prime is 3x squared. Good. So look at this. I almost have it, but I'm missing something. What will I replace 3x squared dx by? So then I have 1/3 in front. I have the integral from u to negative 1/3 du. Now looking at the initial integral and this one, which one is more human, quote unquote? Definitely not this one. It has a cube root, it has a ratio, it has x squared at the top, and blah, blah, blah. This one is just one term. So 1/3 in front, u to negative 1/3 plus 1, u to 2/3 over 2/3 plus a constant c. Of course I flip, so I get 1/2, and I have to go back to x cubed minus 1 to 2/3 plus a constant c. Can we check? Always. The definite integral can always be checked. Okay, let's work on this one for 1 second or 30 seconds. So the integral from sine cubed theta, cosine theta, d theta, when u is sine theta. I lost my count here. This was 11? Yes. So sine cubed, cosine theta, d theta. Sorry, I forgot you don't have the pipe. So that's this one. So sine cubed, cosine theta, d theta. Can anyone dictate? What is du? Very good. So this is my du. And this is my... So then I change the integral. And remember, you cannot have x and u in the same integral. Don't make that mistake. So this is u cubed du, and the answer is... Very good. And then now I have to change back. U was sine theta, sine to the 4th over 4 plus a constant c. Does it make sense? Now let's look at problems that do not have, do not give us the substitution. Okay? On the second page of this handout. Let's start with the integral from sine 5x dx. What bothers you? I know this is not the scientific way, but what do you don't like? I don't like 5x, which is a function inside of sine. That's what I don't like. I agree. So let's say let u be right. So here's how I know whether the substitution I pick is the right one. If du is in the problem. Minor numbers that I can handle. But if du is not in the problem, I won't be able to, I will get stuck. I will not be able to change the integral in x into an integral in y. Let's say if this works, how much is du? 5 dx. That's okay. 5 I can make up anytime. Multiply by 5, divide by 5, I can do anytime I want. So then this is 1/5, the integral from, right, because this is du. Okay, which function prime is sine u? Very good, excellent. Final step? Good. That's it. That's it. Awesome. Let's work on the next one. 1 minute. So cosine x plus 3, everything squared, times sine x dx. Again, this is not the scientific way, but start with a complicated situation. And see if that complicated situation that you would really wish it disappear is the right path to go, to embark on. What am I saying, really? What am I encouraging you to use as u? Exactly, that's what I'm trying to say. Get rid of the complicated stuff, but this will work only and only and only if what? If du can be created or is in the problem, or minor tweaking. Otherwise, it's not going to work. As long as du is in the problem, you're home free. Is du in the problem? Excellent. Therefore, this is, yes, the integral from u squared du. Which one would you prefer? All this or this? Right, because it really helps. Good. So this is nothing else but u cubed over 3 plus a constant c, and it's done. And yes, I cannot leave it in u. U was our tool, but the answer has to be given in x. So this is cosine x plus 3, everything cubed over 3 plus a constant c. Okay, next one. The integral from tangent 3x secant to the 5th 3x dx. This problem has several difficulties. Number one, I don't like the 3x. Number two, I don't like that tangent and secant to the 5th power. So I will recommend taking it slowly. First, and it is possible that we will have to use several substitutions. So I would recommend as the first substitution, get rid of 3x. That's the first thing. So let's say let u be 3x. Assuming the u is in the problem. Is du in the problem? Yes. Du equals 3, because 3x prime is 3 times dx. So I will have to create that 3. That's not a big deal. I can do that anytime. And Tell me what we get at this stage. We have 1/3. We have the integral from tangent u, secant to the 5th u du. Now let's look at and see what we can do here. I see two functions. I see tangent and I see secant to the 5th power. In these kind of examples, normally, I will think of two possibilities. I can no longer use u now, right? U is done. I'm going to say let y be either tangent or secant. This is what I'm thinking of, nothing else, right? The right one, the correct one, is the one that has du in the problem. Okay? So if I find, not du, I'm sorry, dy in this case. So dy equals what? Secant squared x. I'm sorry, I have u. Sorry. Secant squared u du. Okay, let's see if this will work. I can split this into secant squared u, secant squared u, and secant u. This with du will be dy. But then I'm stuck with tangent, I'm stuck with secant, or secant to the 3rd, and tangent. No. It's not going to work. Good, let's try the other one. Dy equals yes. Excellent. Let's try this one. Okay. If I use secant u, I need to have secant tangent du. I have tangent. I have secant. I have 4 more secants and du. This is this. And this is this to the 4th power. This is what I need. Should I do this again? Okay. So if I go this route, that y equals secant u, then dy equals secant tangent du. So I'm coming back to the problem. I have 1/3. I have one of the secants, the tangent, and du will be dy. One of the secants, the tangent I have in front, and du will be dy. How many secants are left? 4. And I know that y is secant u. So what do I write here? I can no longer write secant u because I already had changed it to y. I have y to the 4th. I have 4 secants left, right? Which will be the y to the 4th. Once I move from u to y, I'm done. I can no longer have u in the new integral, okay? Which is 1/3 y to the 5th over 5 plus a constant c, or 1/15. I have to go back to the substitution. I have secant to the 5th. Instead of u, I already had another step before. I put 3x plus a constant c. I know. I agree. Okay, one more here, and then I would like to show you the substitution rule for definite integrals. These are all indefinite so far. Okay, so the integral from x over the square root of x plus 3 dx. What do you think I would like it to go away? Exactly. So let's work on this for a moment. Yes. So let's say x plus 3 is u. Yes. No.
1 dx.
Exactly.
Dx.
So y or u, whatever letter you want to use, it doesn't matter. So dy equals dx. Okay, perfect. And tell me what you get when you move directly and completely from the integral in x to the integral in y. Careful. What do we have in the denominator? Of, yes. So this is clear. What is this going to be replaced by? Well, awesome. Now I have to dig deep and find something that replaces x. I cannot put x in there. Is there anything I can do?
I thought dy will cover x.
No.
Dy will x.
Nope. X is x, dx is dx. They have nothing in common. This piece is here, this piece is here. Now I have to find something that replaces x. And it cannot be in terms of x. What should I do? No, I cannot have y and u in the same integral. Exactly. All I have to do is say y minus 3. Indeed. Awesome. It's right there. I will split it into two pieces. This is y over y, the square root of y. It's y to 1 minus 1/2 minus 3y to minus 1/2. I separate it into fractions. Y over the square root of y. Y over the square root of y is this, 1 minus 1/2. And minus 3 over the square root of y, which is minus 3y to negative 1/2. Is this okay? Is that okay or not? Should I show it? So this is y over the square root of y minus 3 over the square root of y. Copy the base, subtract the exponents. From 1, I subtract 1/2. And then minus 3, and y goes to the top with negative 1/2 as the power. Yes? Tony, are you okay?
Yeah.
Oh, okay, I wasn't sure. Okay, so a 1 minus 1/2 is 1/2. So this is y 1/2 plus 1 over 1/2 plus 1 minus 3, y to negative 1/2 plus 1 over a negative 1/2 plus 1 plus a constant c. I have to clean it up and go back to x plus 3. So 2/3 y to 3/2 minus 6 y to 1/2 plus a constant c. Because negative 1/2 plus 1 is 1/2, and when I flip that, it's 2 over 1. Finally, I put in x plus 3. There is a minor difference between the definite and indefinite with the substitution rule. Any questions on this problem? Okay. So the integral from negative 1 to 2 from 3x minus 1 squared dx. You can say, yeah, I'm going to square 3x minus 1, not a big deal, and finish it up. True. But let's use a substitution. So let's say let u be, what would you like u to be? Right, that's what I want as well. As long as du is in the problem. If du cannot be created with a minor twig, it's not the right substitution. What is du? 3dx. Not a big deal. But now, please do not copy anything. Let's do it together, please. Do not copy the limits of integration. So the integral from, so do not copy these for a moment. What will I have here? U squared indeed. Du. Very good. So please pay attention for a second. When x is -1, how much is u? When x is -1, how much is u? That's it. When x is 2, how much is u? We cannot copy the limits of integration that we had for variable x onto the integral where the variable is y, or u, or t, or whatever else, right? You can no longer copy these two. It's not going to be valid, right? These are limits for x. These are the limits for u. One more time. We plug in -1, -3 minus 1 is -4. We plug in 2, 6 minus 1 is 5. For the definite integrals, I don't have to go back to the previous variable because the answer is going to be a number. It doesn't depend on the variable. So don't look back when you use the substitution rule on a definite integral. There is no need to look back.
So this one we just plug in.
That's it. And the number is done. So this is 1/3 u to the third over 3 from -4 to 5 as we studied in the fundamental theorem of calculus. So now I have to clean it up a little bit and plug in those numbers. So this is 1/9 when I plug in 5, 125, minus when I plug in 4, but it changes to positive 64. So 125 plus 64 is 189 over 9. And this is 21. There's no need to go back. But remember, do not copy the limits of integration from a variable that is x to the variable that is u. You cannot do that. Good. So let's work on a problem now. I know we have 5 minutes left. So let's work on the integral from 3 to 4, x divided by the square root of x squared minus 7 dx. Yes, that's what I recommend. U equals x squared minus 7. Only if du is in the problem. Otherwise, this is not the right substitution. So du will be 2x dx. Do we all agree with 2x dx? Can I make the 2x dx? Of course. I put a 2 and I divide it by 2. So then we have 1/2 in front. Do not copy the limits of integration and tell me what you have as the new integral. So when you plug in 4, okay, you want to do that first. Okay, so 16 minus 7, right? 16 minus 7 is? Right? Okay, and when I plug in 3, it's 9 minus 7, which is? Good, so what do I have now? The top is du. And the bottom is the square root of u. Don't look back. It's a definite integral. We don't need to look back. So this is 1/2. This is u to negative 1/2. U to negative 1/2 plus 1 over negative 1/2 plus 1 from 2 to 9. This is 1/2. When I flip, this will eliminate 1/2 in front. So this is the square root of u, which is 3 minus the square root of 2. Any questions?